Alright, ladies and gentlemen, we're going to solve using elimination. We're going to work a problem on the left, and we're going to write our steps on the right side as we go. So the first problem we're going to do, the first system, is going to be negative 4x minus 2y equals negative 12, and 4x plus 8y equals negative 24. Now, the reason elimination is called elimination is because the whole goal of this method is to identify a variable that we can eliminate. Think about in math, if I had a positive 4 and I wanted to eliminate it, what would I do? I would do negative 4, I would subtract it. So elimination is using the idea of opposites in order to get rid of a variable, meaning make it 0, so that we can solve. Now, our first goal here, so we're going to call this steps. Step 1 is to identify opposites. Now, sometimes you're not going to have opposites, and you're going to have to create it. We will not on this one, but sometimes you will have to multiply if necessary. What would be the opposite of negative 4? 4. So if I combined these together, what would I get? 0. That's the whole goal of elimination. So I don't need to multiply because we already have opposites set up with the variable x. So negative 4 plus 4 gives you 0. So these are gone. And then what does negative 2 and positive 8 make? Positive 6, good. And then negative 12 and negative 24.
Negative 36.
Okay. What's my only step then to get y by itself?
Divide by positive 6.
Oh, so like you would only use this when you have like negative 4x, like negative y.
You can use this method anytime you want. It's most effective when you have opposites. It's also just effective for standard form in general. After we finish problem 1, we're going to practice one that's going to make us multiply so that you can see what it looks like to create elimination if it's not there for you. So if we continue our steps here, step 2, we needed to combine our equations together. That's when this made 0, and those made 6, and those two made negative 36. So our step 2 was combine equations. And then our step 3 was to solve. Now, once we have one variable already identified, this goes back to what you guys are used to. What are we going to do with this negative 6? Yeah, we're going to substitute it back in for y. Now, it doesn't matter which equation you substitute it back into. I always recommend subbing this negative 6 into both equations just to verify that your x's match. Because if we got this wrong and we only substitute it into one equation, we're not going to know that it's wrong, right? We need to put it into both to make sure we get the same x value. So let's go ahead and finish this up. Your step 4 is going to be to check it. And we're going to check it by putting it into both equations. So rewrite your original. Where the y used to be, you can put the negative 6. So what did you guys get when you divided negative 24 divided by negative 4? Positive 6? Okay. And then we'll do it one more time. We'll check that second equation just to make sure we get another positive 6. Jessica, just get a new calculator, please. Alright, both equations gave us a positive 6. So that tells us our solution is 6, negative 6. So the only difference in the elimination method compared to the substitution method is how you start it. Because we still end up substituting here at the end. The difference is when we start to look for opposites and then combine your equations together. So that's the biggest difference. I think once you have opposites, it's a really smooth method for being able to solve. So I'm going to do one more with you guys, but we're going to do one where we have to create our own opposites. Alright, so this will be our example 2. And I know these problems are really long. I just flipped my page to the back.
So our coordinate would be 6, negative 6?
Our coordinate? Yes, x was 6, y was negative 6 on that first one.
Yeah, the top one is a negative 6.
Oh, I thought it was
So you have negative 2x minus 9y equals negative 25. And negative 4x minus 9y equals negative 23. Do we have opposites?
No.
But we're close on which variable? The y's really close. Now the x actually isn't that far either. You can choose which one you would like to do opposites. Let's say right here I have a negative 4. What could I multiply by to make this the opposite? What's the opposite of negative 4? Positive 4. So what would I multiply by to make this negative 2 a positive 4? Negative 2. So that's how you fix it if you want it to be elimination, is I would multiply a negative 2 all the way across. Personally, I would go the y, because what's the opposite of negative 9? Positive 9. So all I need to do is change this to a positive. Well, how do I change this to a positive 9?
times by negative 4.
Yeah, I could take this whole top equation. It doesn't matter which one you use. I could multiply that whole equation by a negative 1, because when I do the one term, I have to do to all of it. So this can become 2x plus 9y equals positive 25. Because multiplying by that negative 1, all it does is change the sign of everything. This is going to stay the same. So once we have created opposites, multiply if necessary, right? That was our first step.
Wait, so if you were gonna, I'm sorry, but if you were gonna multiply with the negative 2x and the negative 4, then you just multiply by negative 2.
Yes, if you wanted to make the x the opposite, you would multiply the top by negative 2. I just figured it would be easier to multiply by a negative 1 than a negative 2.
Yeah.
So from here, what was our step 2 that we wrote?
Combine.
Combine equations. So what's 2 minus 4?
Negative.
Negative 2, so I have negative 2x. What's positive 9 and a negative 9?
0.
That's the goal. We wanted to eliminate one variable. Now we're going to have something we can actually solve. And what do we have on the right? 2. Done with that. And then take a minute, go ahead and plug the negative 1, substitute it, put it back into both equations. We'll make sure our y values match, and then we'll be good on problem 2.
So do we do the new equation for the first one or the normal equation?
Great question. If you're choosing where you want to substitute, I will never substitute into something I created, because what if I messed it up? If I put an answer back into something that I did incorrectly, then it's a false check. It's not really going to help. So that's a great question. Always recommend taking your answer and substituting into the originals versus the new one.
Okay.
So I'm going to go back up to this first equation we started with. All right, check my math on that. Can anybody confirm positive 3? Okay, let's double check in the other one, then we'll be good. So if we were to graph this, what would happen with our 2 lines? Good. We just found their intersection. They would intersect at -1, 3. So that would be our solution.